Okay, here we go. Starting on page 362, I will read what it says. Before I start, don't look at your book. Raise your hand. It's not really in there exactly. Sort of it is. Don't read your book. Raise your hand if you can tell me the definition of a log. Did you know the question I was going to ask if I started?
That's like
I know. And I still get like 2 or 3 hands. Raise your hand if you know the definition of a log.
Yeah.
I got to keep asking then. Go, Allie. What do you think?
Oh, like the exponent that you raise the base to.
Yeah, the exponent you raise a base to get your desired result. So if I have log 100, I'm asking you, what exponent do I have to raise this base to get the result 100? The answer is 2. I'm going to ask that tomorrow. I expect all hands. All right, here we go. When rewriting expressions in exponential and logarithmic form, it is helpful to remember that a logarithm is an exponent. The exponential statement, 2 to the third equals 8, is equivalent to the logarithmic statement, log base 2 of 8 equals 3. Make sure you are saying it correctly. So if I ask you to read something, make sure you say log base 2. Don't say log 2 8 equals 3. Log base 2 of 8 equals 3. Notice that the logarithmic expression is equal to 3, which is the exponent in the exponential expression. Like I said, a lot of this is review. So 1 and 2 are review. Let's go ahead and do those on your own. Number 1, express each exponential statement as a log. Number 2, express each log as an exponent. It should all be without a calculator, without looking up old notes, hopefully. Raise your hand if you are done with 1 and 2. Okay, I'll give you more time. What about Ellen? What is it? It is the log base. Just like log base 10 is so common that we drop the 10. We can't really drop it. We just kind of give it a new name. So log base E is ln. Yep. So the first one, remember the base of the exponent is the base of the log. So if this is base 3, my log is base 3. Remember the answer to the log is the exponent. So this one has a log base of 6. The result I want is 1 over 36. And the answer to the log is the exponent. Next one. So this is going to be log base E of 1. And the answer is the exponent. We should rewrite log base E as ln. I don't know if I would take off for it, but again, not something you'd see on an answer key or in your book. You wouldn't see log base E very often. Number 2 is the opposite. The base of the log is the base of the exponent. The answer is the exponent. These also make sense because they're numbers you can think about. So make sure you could do it if it said log base A of B equals C. Can somebody tell me what that would be as an exponential statement?
A x to the c equals b.
Yep. The answer to the log is the exponent. The log base and the exponent base are the same. So let's get to this one. That is a log of base e. So the exponent is base e. That is your exponent. Any questions on 1 or 2? That's review. 3 takes a little more time, a little more thought. It says evaluate each expression without a calculator. You might have to do some chicken scratch off to the side. I'll start with the first one, then I'll give you more time if you want. I am trying to figure out the exponent that I have to raise 2 to get 32. And if I don't know and I don't have a calculator, I do this. Well, 2 to the first is 2. 2 to the second, 2 times 2 is 4. 2 times 2 times 2 is 8. Multiply by 2 again. Multiply by 2 again. There we go. 2 to the 5th power is 32. You can have whatever work you want, but make sure I know that your answer is 5. Please don't write this whole thing as your answer. Evaluate means, what is it? It is 5.
So if I did like the 2 to the first, 2 to like second in my head, do I have like?
Oh no, you don't have to write that down.
Okay. If I like write the whole thing out and then just circle the 5, what do you?
I'll take that. Yeah. Yeah. So if you write 2 to the 5th equals 32 and you circle that, I'll take that. But if you just leave it, you might miss a half. B, you might want to ask yourself 4 to what power is 64? That's probably what you thought in your head anyway. Well, 4 to the first is 4. 4 times 4 is 16. 4 times 4 times 4, maybe we don't know. So we'll just do some scratch work. 16 times 4. 6 times 4 is 24. 4 times 1 is 4. Add 2. There we go. 4 to the third. Oh, that's not my answer. 4 to the third is 64. So what is my answer? Right. That would be, put it in the denominator. So my answer, -3. Did we do C without really any work? Good. Most of us know that 3 to the third is 27. If you don't, do some scratch work. This one is 12 to what exponent equals 1? That's confusing. What is that? 0. Anything to the 0 power, 1. Number 4, why is the value of log base -2 of 16 undefined? Short answer, I'll tell you. The base and the argument must be positive. You can write that down. The base and the argument must be positive. We're not going to get into why that is and how negatives work and all the things like that. We've talked briefly about things before with the argument being negative.
So can I have like -2 to the 16th power? Like, is that okay? Or like that's how it works?
Right. The base can't be negative.
So it's 16 argument then.
The 16 is the argument, so that's not the problem here. Yeah, it's the base of -2. All right, read number 5 to yourself. You don't have to write your explanation. Just give it to me if I call on you. Abby, what do you think? Is he correct?
No,
No. Why not?
because -2 isn't the base of the argument.
Right. The base is 3. The argument's 1/9. That's okay. The answer can be negative. The answer is just the exponent. So he is wrong. The base and the argument have to be positive. The result, or what is the exponent, the answer of the log, can be negative.
Oh, we need to go with this.
Okay, good. So reviewing product quotient and power property with some actual numerical values. It says log base 2 of 4 plus log base 2 of 8. They kind of give you a hint in the name, product property, which tells me multiplication. I can take these 2 logs that are added and turn it into 1 log of multiplication. Anybody tell me what that 1 log is going to be?
Log 2.
Don't say it that way.
Log base.
There we go. Log base 2
of 32.
Yes. Log base 2 of 32. If this was log base 2 and this was log base 20, we wouldn't touch them. We would just leave them separate like they are. The only way you can combine them is if they have the same base, which they do, and that base carries through to the property. So 4 times 8, 32. Under here, you're going to do these individually. So 2 to what power is 4? 2. 2 to what exponent is 8? 3. We know that adds up to 5. Does this also equal 5? Yeah, we did that one earlier. 2 to the 5th is 32. Try the next one on your own.
Okay, this is my board.
Okay. These are ones you can do in your head. 3 to the 3rd is 27. 3 to the 1st is 3. 3 minus 1 is 2. And it does check out because I would need an exponent of 2 to get 9. Power property. Power property, remember this coefficient could be written as my exponent. So I would write log base 5 of 25 squared. I could do 25 squared in my head. I should say in my head on paper. That's one I don't always remember because I know I can find it if I don't remember. So we should be able to do this kind of work. 5 times 5 is 25. 5 times 2 is 10. Add that. We remember how to do this multiplication, right?
Yep.
Good. 2 times 5 is 10. 2 times 2 is 4, plus 1 more is 5. You multiply by each thing, and once you're done with that, you put a 0 and you go to 2.
I forget
So this is the same as log 620. We should be remembering how to do multiplication like this. Yes.
If it has decimals, that's a different story.
Well, that
Decimals
doesn't
just
change
count
any.
as fives, and you
I
do
decimals-
forgot how many you're supposed to do. Are you supposed to count the lowest number, or like them in total?
Well, it depends if you're adding, multiplying, or dividing.
Never mind.
We can get into it later if you want to. All right, let's go ahead and finish this one. Log base 5 of 25 is
5,
5 to the 5th is 25.
2.
5 to the 2nd is 25. 2 times 2 is 4. I'm not really sure if this checks out. I'm going to do some work, even though you wouldn't be required to. Might be nice to check. So let's see. 5 to the 1st is 5. 5 to the 2nd is 25. What's 5 to the 3rd? Good. I'm going to have to multiply by 5 again. 5 times 5 is 25. 5 times 2 is 10. Add that. 5, add 1 more. That works out. 7, nothing new here. Number 7, expand. Go ahead, do those on your own. You do them on your paper, I'll do them up here.
I have no nice thing to say about it.
The top one I did in 2 steps. Then the rest of them I just wrote the final answer. We have division, so that's subtraction. Make sure you keep the log base. If you don't, it's going to be wrong. Log base 7, those both are base 7. Then I do my power property and I bring that down as my coefficient. B, do we have questions on B? C is no different. ln is log base E. So this is still a log base E.
Doesn't that actually make a word?
A what?
A word. Is it links? Is that a word? Isn't that an animal?
Links is a,
Wait,
There's a Y
would it be wrong if I just put
Yeah.
log?
Oh,
instead of, like,
Oh,
no, not necessarily.
that's what I've been thinking about like this whole time.
I love
That's
it.
not how you spell that though.
IN or is it an
L.
We did one and it almost
Oh,
spelled
why?
baloney.
Almost spelled what?
Baloney. It was like long, but it was.
Oh,
baloney at the
I
end,
could
so
see that.
I can do it.
8.
So long.
Number 8. Assume that x is any real number and decide whether the statement is always true, sometimes true, or never true. If the statement is sometimes true, give the condition for which it is true. I will give you a heads up. I did not get all these right when I did it the first time. So there's some trickery in here. Nobody last hour got all 5 right. So go slow.
the first one? I feel like
I'm quitting.
Give it a try, and then I'll go over all 5. Don't share your answers with anybody.
There was not even an X in the first one. No, I'm guessing. Okay.
Don't share your answers.
skipping C, that looks hard.
No calculator.
You literally forgot the
Where
X
does
part.
it say? No calculator?
I say. It's just in
Okay.
here.
That doesn't.
If I wouldn't told you it was tricky, then you would have been fine. The tricky part comes with something small that's set in the directions that you have to be careful with.
Stupid numbers. E is not a number. Why is it confusing? Well, I did this wrong because that does not even make sense.
Wow, that's a really true.
In fact, I don't know what a real number is. I remember we did these.
I gave you guys a little more hints than I should have on the trickery part.
We did this circle thing.
Raise your hand if you'd like some more time.
I got this. With a lie, I don't got this. It's false confidence.
I feel like the calculator's the way to do it. That bothers me. I feel like no end. That like you put
No.
the graphing calculator.
I tell myself every day to not let it bother me too, but
It's
you just get past it after a while.
What?
Sometimes they put 2 calculators in one pouch,
What?
or they put it up top where there's never been a calculator.
It's irritating. And like, how do you gonna put that like graphing calculator in the row with the non-graphing calculator?
I don't know. Okay. I will give the answers and then I will give the explanations. The first one, A. Never true.
What?
Raise your hand if you got that one right. Keep your hand up until you get one wrong, and then we put our hand down. So far, we've got 3 contestants. Four
I'm
contestants.
going down. I just guessed. Well, I'm going down.
A, never true. B, always true.
Oh, for 2.
We've got 3 people in still. Lydia,
I
A.
already got it wrong.
Dang it. C, we've got 3 people left. C, sometimes true.
Oh, I skipped that one.
There's a stipulation. Sometimes when.
That's a wonderful question. I said I guess.
X is even greater than 0.
Good guess. You don't have a when? Okay, hands down. D, sometimes true, and I won't tell you yet, but when we go over it, I will.
Look at that.
E, sometimes true.
Oh, dang, that's like
So
that.
I
That's
got
where
over 5.
that's where it dropped out of.
Okay,
I got 4 or 5.
I do believe everybody should have gotten the first one.
Nope.
No, I confused.
Mary, tell me what's wrong with the first one, because I see subtraction, I see division, I don't see any problem.
There's a difference between like dividing the log answers and like doing it right. I don't know exactly what that is.
Oh, I got
Jordan?
it. You have log 7 over log 5, but it's not log
Oh, it
7
shouldn't
over.
be.
It should be
Yeah, it should be log.
7.
Yeah.
one log.
Yeah.
Yeah, if you look back at your properties, it's not log with subtraction and 2 logs with division, it's combined. If there's subtraction, that turns into a single log with division, not log over log.
Sometimes I write 2 logs and then I put in parentheses.
I don't even know what I'm doing.
Same difference.
So this one is never true.
No.
B, log of base 5 and exponent of base 5 are inverses, so those cancel out and you get x equals x. So that is always true. Now C, exponent base 2, log of base 2, inverses, that cancels out. I get x squared equals x squared. So why, if this is always true, why did the same logic make this one sometimes? Because the base and the argument have to be positive, and we forgot to check that. So if you look at C, if I put in any x's that I want, it's not true all of the time. If I put in an x value of what? would give me a problem.
-1.
-1 squared is positive, so that would be okay.
-100.
What number squared is not positive? 0. This is true always, 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 except x can't be 0, because if x is 0 and I square 0, now my argument is 0, which is not positive. We say it's either negative or positive. But in B, it doesn't matter, because look, in B, if I put in 0, what's 5 to the 0? 1. What's 5 to the negative first? 1/5. There's no number I could put in for x, positive, negative, 0, to make the argument negative. So this is where the trickery comes in. I wouldn't probably give one like this on a quiz, because I want you to see that those cancel and you get x squared equals x squared. But it is a good thing to discuss. If you reread this closely, this is kind of where the hint is. X is any real number. And it can't be any real number. It can't be 0 for that one. So by your logic, I could see how you would say always true, because this does seem to work out. The only time it doesn't is when x is 0. D. This is sometimes true. That sometimes is when x is what?
1.
1.
Oh, you're
So
right.
let's do
Oh, that's, I thought I got that right. Oh, how did I get that extra?
addition would be multiplication. Division for your subtraction. So that's an x. And I want this to equal, shoot, I forgot my 4. Log base 4, 15. Well, this is your 15, so this would have to be a 1. I didn't explain that very well. Do you see what I'm saying there? The only time this is true, the only time this could equal this, is if x is 1. So sometimes it is true when that x is 1. The last one, if you put always true, that's kind of what I guess you would pick, and that's a pretty good answer. But can I put any x's in here all of the time forever? No, I have to put x's greater than 0. So it is true if x is greater than 0. So this was sort of new, but not really any new information, just extra thinking. I have one new thing for you. Yes?
Isn't that always true because the conditions say that x is a real number? Like you said it's greater.
-7 is a real number. You're thinking like positive integers.
But isn't that what real numbers are? It's greater.
This is a real number. Real numbers are anything without I. Pi is a real number.
Oh, okay.
Yeah.
Imaginary numbers are my best friend.
Oh, I was thinking of natural.
Yeah, you were thinking something. Alrighty. In the margins of your book, don't flip the page. I'd like you to write.
I didn't look. I just wanted to see like.
I said don't flip the page. There's something I do not want you to see on the next page. It's not that big of a deal.
I ripped it.
Jillian, give me any number from 1 to 100. No.
3.
Make it difficult. Just pick one.
20.
20. Jillian, give me a number bigger than 20.
33.
Everybody write this on your paper. Log base 20 of 33. Can we do that without a calculator?
No.
Could you tell me what number it's between? Like it's between 1 and 2. It's between 2 and 3.
No.
Well, yes, you can. 20 to the first is what number?
200.
20 to the first?
20.
What's 20 to the second?
400.
So isn't this going to have to be somewhere between an exponent of 1 and 2?
Yeah.
So you should always be able to tell me. I know it's 1 point something or 2 point something, and that's as far as I can get. All right, in your calculator, type log base 20 of 33. So you're in your main screen. Remember, you type math all the way up or down until you get to log base.
How many decimals?
Oh, I don't care. 1.167162898. Does that mean it stops there? No, it probably goes on forever. On your paper, either below this or to the side of it, like you to write log 33 over log 20. Now tell me, is this log base 20 still?
No.
You would see the 20, right? Is it log base 33 of 33?
No.
It's log base 10. So if you're typing that in your calculator, you don't have to use the fancy button. Log base 10s, you can just use the log button right by the 7. So you're typing log of 33, close that parentheses, divided by log 20.
This is why math is confusing.
Is there like an explanation?
I don't have that. I would have to look into how this works. So back in the day,
Oh, the rest.
our calculators, the calculator I grew up with in high school, didn't have the fancy button that you could do this with. So every time I saw a log of not 10, I had to do this. This is called change of base.
Oh.
Because notice the base here was base 20, and these are both base 10. There won't be a lot of these, but if it says rewrite this using the change of base formula, you'd be required to do this. Or if it says rewrite this, rewrite this with a base of 10, do that. Rewrite this log of base 12 with a log base 10. It's very simple. Kind of like over here, your 33 is still like on top. It's above the 20, and it is the one that is on top. So this is log 19 over log 12. It is optional to write the 10s. Here's what I want you to do. Write a formula for this change of base. That's why I don't want you to turn the page, because they start giving it to you on the next page. So write your formula for what we've just discovered.
Oh, yeah. We have to put 10.
Optional. Wyatt, you got a formula? What do you have? You don't have it?
I have log base A of B
Very good.
equals C.
Is that what you ended with? Log base A, B equals C?
Then it will be log B over log.
There we go. You can pick any letters you want. You need to have a base and an argument. And then over here, these are base 10. You can write the 10 or you can leave it off. Make sure that whatever you put here is the one on the top. How many of you had exactly that? Okay. On the next page, you don't really have to rewrite it because I think you got it. But on the next page, it asks for your change of base formula here. They get you started with log base B of X. So write down what that would equal. Thomas, what would that equal?
That would equal log X over log B.
And what's the base of both of these logs?
10.
10. The base of the original was base B. That's called change of base. That's the only new part for today. Everything else was review and more practice. There you go.